simple numerical problems on properties of steam. Let us solve this first problem first. This is determine the enthalpy of 3 kg of steam at 40 bar pressure when it is dry steam, or it is wet steam with dryness fraction of 0.85, and it is superheated at 350.35 degree centigrade. So let us understand the problem first. Suppose this is a TH diagram, temperature enthalpy diagram, and this curve represents the formation of steam at different stages. OA is the sensible heat, and this is for a 40 bar pressure. So OA is the sensible heat HF and total heat of dry steam. And if the steam is wet steam, then suppose this is the condition of the steam with dryness fraction X. This is HF plus X HFG. And if the steam is superheated and at condition 3, then this is equal to total heat H equal to Hg plus Hg, the dry heat, this part, plus Cp T soap minus Ts, temperature of saturated steam. And this temperature is Ts, and at condition 3, temperature of superheated steam. And this is at a pressure of 40 bar. So for this we have to use one steam table, and with the help of steam table we are going to solve the problem first. Steam is at a pressure of 40 bar. So from steam table, pressure basis steam table, we can see for pressure 40 bar, 250.35, this is the temperature of saturated steam at 40 bar pressure. Sensible heat is 1087.4 kilojoule per kg of steam. Latent heat of evaporation is 1713.5 kilojoule, and the total heat of dry steam is 2800.8 kilojoule per kg of steam. Now these are the data we require from the steam table. So from steam table at 20 bar pressure, we get saturation temperature Ts is equal to 35 degree centigrade. Sensible heat HF is equal to, then latent heat of vaporization is HFG, and also total heat of dry steam, that is Hg, is equal to. So with this data from the steam table we can solve the problem. So the first problem is when the steam is wet steam with a dryness fraction of 0.85. Total heat H is equal to M, the mass of steam, into HF plus X, dryness fraction of steam, into HFG, 3 kg. HF is so the total heat or enthalpy of wet steam is equal to 7631.6 kilojoule, because we multiply the specific enthalpy by the mass M, which is equal to 3 kg. Now second part of the problem is, if the steam is dry saturated, then total heat or enthalpy H equal to M into Hg. So from steam table we can directly get the value of Hg, enthalpy of dry saturated steam. So the enthalpy of dry saturated steam for 3 kg of steam is 8402.4 kilojoule. And the last part is, if the steam is superheated at 350.35 degree centrifugal. Then Hg, total heat of dry steam, plus the degree of superheat, heat of superheat, then that is equal to Cpg, specific heat of superheated steam at constant pressure, multiplied by degree of superheat, that is equal to T sup minus Ts. And if we put the values, now we have to assume the value of Cpg. Suppose Cpg is equal to 1.9 kilojoule per kg per Kelvin, specific heat of superheated steam. And if we put that value, T sup is given 350.35 and Ts, saturated temperature of saturated steam is. So we have found out all the required enthalpies for 3 different conditions. Now we will solve a problem on internal energy of steam. In the previous classes we have discussed the internal energy of steam, the relation between enthalpy, internal energy and work done. The total heat of steam is equal to sensible heat plus the latent heat of evaporation. The mathematical relation is this: H is the total enthalpy of the steam, U is the internal energy, and PVG, this is the work done during the evaporation process. There are 3 different variations of this formula depending on the quality of steam. The steam may be wet steam, steam may be dry steam, and steam it may be superheated steam. We will solve a problem on wet steam. We have to calculate the internal energy of 1 kg of steam when its pressure is 20 bar and it is 90% dry. That means dryness fraction X is equal to 0.9. So we can rewrite the formula that general formula for internal energy is equal to enthalpy minus work done. In our case, we will use this formula for wet steam. And for wet steam, internal energy of wet steam is equal to the enthalpy of wet steam minus the work done by the wet steam. We will find the enthalpy of wet steam, which is equal to HF plus XHFG. This is the enthalpy of wet steam. Then value of HF and HFG we will get from the steam table. Pressure P is given, and also the value of Vg, the specific volume of dry steam, we will get it from the steam table. So for a steam table, you can see this is the pressure, and for 20 bar pressure we need these values only. This time we need the value of HF and HFG, and also the specific volume Vg. From steam table we got these values at 20 bar pressure. We will use this formula for internal energy. Now the value of sensible heat at 20 bar pressure is 908.47 kilojoule per kg of steam, and the latent heat of vaporization is equal to 1889.8 kilojoule per kg of steam. And also at that pressure, the specific volume of dry saturated steam is 0.09959 meter cube per kg of steam. So first let us find out the H weight. Enthalpy of H steam is equal to sensible heat plus dryness fraction into HFG, latent heat of vaporization. So enthalpy for wet steam is 2609.29 kilojoule per kg of steam. Now we have to find out the value of x p v z, and value of x is 0.9, and p, the pressure p is equal to 20 bar pressure, which is equal to 20 into 10 to the power 5 Newton per meter square. We have already find out the H weight in kilojoule per kg. So we have to use the pressure in the unit kilonewton per meter square. So that will be equal to 2000 kilonewton per meter square. So we'll put this value 2099, and now this unit will be in kilojoule per kg. So the internal energy of wet steam that we have to determine is equal to, so this is the value we had to calculate, that is the internal energy of 1 kg of steam when its pressure is 20 bar and dryness fraction is 0.9. So from this problem we can also understand that out of the total heat of the steam, a part is used to do the external work, PV work, which in this case is 179.26 kilojoule per kg, and rest is used to increase the internal energy of the steam. So a very small fraction of heat is used for doing external PV work. Our next problem is to determine the condition of steam, that is the quality of steam, at a pressure of 9 bar if 2600 kilojoule per kg of heat is required to produce it from water at 0 degrees centigrade. The total heat is given 2600 kilojoule per kg because this much of heat is required to produce it from water at 0 degrees centigrade, which is the definition of total heat of water or steam. So we are given that pressure is equal to 9 bar and total heat is 2600 kilojoule per kg of steam. So you remember this value of H, and we'll look at the steam table. So for steam table at a pressure of 9 bar, the value of enthalpies are sensible heat is 742.56 kilojoule per kg and latent heat of evaporation is 2030.5 kilojoule per kg, and the total heat of dry saturated steam is 2773 kilojoule per kg. Total heat of dry saturated steam. The value given in our problem is 2600 kilojoule per kg. The total heat of the steam of 1 kg. Now you look at this values, 2600 is less than 2773 kilojoule per kg. That means this steam is not even dry. This is not dry steam. So if it is not dry steam, it must be wet steam. And if the steam is wet, it will have some dryness fraction X, and that we are to determine. So we'll use these three values HF, HFG and 2600 to determine the dryness fraction of steam. From steam table we get HF is equal to this much and HFG equal to this much of kilojoule per kg. And the total heat H is given 2600 kilojoule per kg. And we have already find out that the steam is wet steam. Therefore, H is equal to HF plus XHFG. Okay, so 2600 is equal to HF is 742.56 plus X is not given, that we are to find out into HFG is equal to 2030.5. So from this we will get the value of X, which is equal to 2600 minus 742.56 divided by 2030.5, and this comes out to be approximately 0.915, and this is the dryness fraction of the steam that we have to finally determine the condition of the steam. The condition is, or quality of steam is, wet steam with dryness fraction of 0.91. That means 91.5% of the steam is dry and rest 8.5% of the steam is water particle in suspension. So that is called dryness fraction. That means the fraction of the steam which is totally dry, and rest fraction is the water particles in suspension with the wet steam.